Hello everyone, my name is Rohit Patil and today's topic of our presentation is optimization algorithm, SGD, ADAM and RMSProp. So let's begin. So before going further, let's see what is an optimization algorithm. So an optimization algorithm are the method used in machine learning and deep learning to minimize and maximize a function, usually the loss function by adjusting the model's parameter, weights and biases. In simple words, they help the model learn better and faster by finding the optimal values of a parameter that reduce error in the predictions. So let's understand by an example. Suppose we are training a neural network to predict the house price. The model predict a price of $2,500, but the actual price is $300. The loss function calculates this error. An optimization algorithm like SGD will adjust the weight in the network slightly to reduce the error. Over many iterations, the model learned the correct pattern and predict price closely to its value. So now let's understand what are the optimization algorithms. Simply, they are the engine that train our model. They work by adjusting the model parameters, weight and biases to minimize the error, which we call the loss function, and make the model more accurate. Now let's look at the three common types of optimization algorithm. First one is stochastic gradient descent. This is the most basic one. It's fast because it updates the model by looking at one data point at a time. Second one is root mean square propagation. This is an adaptive algorithm. It's smart than the SGD because it automatically adjusts the learning rate, which help improving the training performance, speed and performance. And third one is adaptive moment estimation, which is also called ADAM. This is the most popular choice today. It's also adaptive like RMSProp, but it adds momentum, which is like remembering the direction of past update. This combination make it very efficient and effective for most deep learning models. Now let's look at how these three optimizers actually work. So first one is stochastic gradient descent. This is one straightforward. It calculates the error gradient. Just use one data point for a small batch. Then it updates the model weight in the exact opposite direction of that gradient to reduce the error. Because it uses only one sample, its path is noisy, taking small, random looking steps toward the solution. So second one is RMSprop. RMSprop is more adaptive. It keeps a moving average of a squared gradient to figure out how much the gradient is changing. The key idea is if the gradient is large, it takes a smaller step. If the gradient is small, it takes a larger step. This auto tuning helps stabilize the training process. Third one is Adam. Adam is the most popular because it combines the both best of the both worlds. It takes the adaptive learning rate idea from RMS prop and momentum, which is an average of past gradient. This helps it remember its general direction. By tracking both the mean and variance of the gradients, it's fast, efficient, and the go-to choice for the most deep net. So let's see what are the limitation of these three optimizers. First one is stochastic gradient descent. So stochastic gradient descent, it use random sampling can cause fluctuation in training. It may take iteration to reach minimum. Needs careful adjustment. Too high leads to divergence. Too low leads to slow learning. Stuck in local minima or saddle point in complex loss surface. So now let's talk about the limitations faced by RMS prop. So RMS prop performance depends on decay rate and learning rate. It may stop improving if learning rate becomes too small. It doesn't always handle long-term trends in gradient direction. So let's talk about the limitation of ADAM. It's first it store second and estimate for each parameter. It may converge faster but to suboptimal minimum. Performance can vary with beta 1, beta 2 and n choices. Less theoretical conversion guaranteed compared to SGD. So, concluding it, optimization algorithms are the core of machine learning training, help model minimize loss and improve accuracy by updating weight efficiently. SGD is the simplest and fastest method for large dataset, but it may oscillate and need learning rate tuning. RMS Pro improves on SGD with adaptive learning rate, stabilizing training, especially in RNNs or non-stationary problem. Adam combines the strength of momentum and RMSprop, making it most widely optimized due to its speed, adaptability, and reliability. Each algorithm has its own trade-offs. SGD is simpler but slower. RMSprop is adaptive but parameter sensitive. Adam fast but memory heavy. Thank you.